Good afternoon. Welcome to the Motor Carriers Insurance Education Foundation Truck Stop webinar. These webinars presented on the second Thursday of each month at 2 p.m. Eastern Time. These presentations are presented as industry updates for informational purposes only and do not qualify for state CE credits. If you're seeking state CE credits, you can visit our website or email us at mcief.org, and Beth will let you know how our programs that do qualify for state CE credit. If you have any questions, type them in the chat window. They will be answered as time allows, or most often answered after the webinar is over by email that we can visit or send to everybody. If you experience audio problems, please send us a note again in the chat window or call us at 800-741-484 and we'll try to rectify those. Platooning and trucks without drivers, closer than you think. Presented by Glynn Spangenberg, Spangenberg Partners. I think he's actually. When I first heard Glynn, it was on the Road Dog radio show, and Mark called it Spanky, so he said I can call it Spanky too. Tell me a little bit about you, and I think you got this partnership. Now you're aligned with someone else, or you're not, Mark? Glenn, we'll go through this part of it. Go ahead and say hello to everybody. These are people you're talking to, probably represent, our membership represents about 85–90% of everybody who's writing trucking. And we've been hearing about autonomous vehicles, and I was quite impressed with the show that when you did Mark's show that this might be closer than you think. I was a part of San Francisco about 5 years ago, had that autonomous vehicles symposium out there. I was on a panel out there, so 2,000 people. There's just too much money in this industry for these things not to happen. And I was impressed by the platooning being a problem to train new drivers and economy and all as one of the first levels. And then when you went through this and you now align yourself with locomotion on this part of it, I see this as a first step that makes a lot of sense to everybody in this. So I appreciate you sharing your time with us and letting people know it might be closer than we think in this part.
That's right.
Speak about it, tell us about it, then we'll go look through your slides here in a minute, Glynn.
Sounds good. Thank you, Tommy. Well, I am Glynn Spangenberg. I am now the Chief Commercial Officer at Locomation. Locomation is a mashup of locomotion and automation to form the one word, the name of our company. And the Spangenberg Partners, I still own that as the Chairman and Chief Advisor. And it is just a boutique firm that helps advanced trucking technology firms come to market, make a market. And that's frankly how I was introduced to Locomation back in April of 2019. Great group of folks from Carnegie Mellon University's National Robotics and Engineering Center. My background, I grew up in the trucking industry. I earned the truck transport merit badge as a Boy Scout in 1973, and I just fell in love with the industry altogether. The Spanky nickname actually it comes from probably the last name spelling, but we actually got it from my dad. He was a naval aviator, and his handle was Spanky, and so I'm proud to actually bear that nickname in the industry and thank my dad for the service that he gave to our great country. And it is great to be on the show with you here, Tommy.
As you just said, it's also a pleasure to talk about your father like that. Same thing with me, as you know, my father was a trucker, so I'm able to share with people his example. So it's a pleasure, as old as we are, and he's not with us anymore, that always able to circle back around him for our heritage means a whole lot. Okay, Glenn, now let's move to your slides. Take it over.
You bet. Thank you, Tommy. I'll just say our mantra is launch earlier, scale faster. This is a deliberate path to autonomous trucking. So even as I kick this off, I want to just briefly talk about how big the problem is in terms of really truly solo autonomous trucks, no driver driving on the roadways. This is an extremely complicated problem to solve. And we've seen over time how some of these, new early entrants into the marketplace have stated that they have autonomous trucks on the road by 2015, and then 16, and then 17, and then 18, and of course the timeline keeps slipping. Well, the reason it keeps slipping is because it's an extremely complicated problem to solve when you have to actually teach the machine how to operate and function without a human involved under every situation. And what happens is you have developers who are telling the machine that when it sees this situation, it needs to respond like this. When it sees this different situation, it needs to respond differently. Well, the problem is the world is always changing. The world around us, especially in a driving environment where you have pedestrians and you have other vehicles, and then of course you have people that aren't even paying attention behind the wheels of the cars and the trucks these days. And so being able to deal with this, all of the various problems and code to it and make it rational for the machine to understand, and then you introduce all the dynamics to it. It really is what they refer to as the long tail problem. And the long tail problem says that over the course of time, it's easy to deal with some of the big issues. Stop at a red light, go at a green light, be cautious at a yellow light, stop at a stop sign, and so forth. But the hardtail of the problem is when you're dealing with somebody, for example, carrying a stop sign, and the machine says, I don't know what to do. Do I stop or do I go? It looks like a pedestrian, but a stop sign. And so a lot of complications that are introduced into the way that the machine has to function on the road. And I refer to it as a machine because it's an inanimate object. I mean, literally it is, it has no human cognitive reasoning capabilities other than what it's been told and programmed to do. So when we talk about a deliberate path to autonomous trucking, we're talking about getting into the stream of the activity that's taking place today on the roadways and coming up with a way that the autonomous truck can actually be introduced in a scalable fashion. And I want to just maybe kick off the conversation by pointing out that Locomation is the only autonomous truck company that has signed actual purchase order agreements. The first one we signed with Wilson Logistics in 2020 was for 1,120 ARC systems. Now, ARC stands for Autonomous Relay Convoy, and it's the first product. I'll share with you a bit more about that in just a moment, but the first product that we're putting on the roadway is an autonomous follower. So this is a human-guided convoy where you have a human in the loop driving the lead vehicle, and then you have a follower vehicle with the driver off duty, not driving, but the vehicle is still in motion, running in autonomy mode. So these are 1,120 ARC systems that we'll be deploying on 11 autonomous relay network segments. And the segments, again, I'll share with you in just a minute what that means. But these are round trip areas, relay areas, and transport segments that are based on the current interstate system. The segments that Wilson is focused on are worth about $360 million in revenue and about $54 million in net profit. I'll share with you in just a moment how those numbers stack up. The second agreement we recently signed was with a company called PGT Trucking. This is for 1,000 autonomous relay convoy systems that they're going to be deploying on over 30 autonomous relay network segments, and they're going to be focused on about a $340 million revenue run in those lanes and about $51 million in net profit. So these two companies essentially have validated our approach to the market, and we do have more announcements coming, so you'll have to stand by for that.
Glenn, I thought it was a thing that instead, I used to work Platoon, the convoy is the one that you're using. It means the same basic thing. Although you could play the song, the convoy song now, right? To emphasize where you are.
Yes, exactly right. Yeah, very good point there, Tommy. So we're taking a turnkey approach to how we're deploying autonomous technology. So we have 3 parts to our solution. One, of course, is the autonomous vehicles. Now, we've got 4 different phases that we'll roll out. Don't want to confuse you at this point because I'm going to talk about that in just a moment. But the autonomous trucking systems really form the basis of what you're going to see in this entire solution, but they're not the end point. They're just one component in how these things need to take place. And primarily, it's because the truck can't just wake up like a human does and go to work and know exactly what to do and with whom to do it, and then clock off at the end of the day and go home. It doesn't work like that. So we've introduced the autonomous relay network and the digital transportation system in order to assist fleets that want to deploy an autonomous trucking service. So our entire goal is about enabling the clients we serve to deploy a service like this and actually offer autonomous trucking services to the shippers. And so the autonomous relay network, you see that in the middle, this tells us where the opportunity is. So it tells us where autonomous trucks can operate safely and profitably by identifying the freight that moves between the points on the autonomous relay network. So the entire US truckload marketplace is worth about $350 billion in total spend. But the value is in knowing exactly what freight is ready for autonomy today. And we've identified about 120 billion of that marketplace that is ready right now. And so by deploying the autonomous relay network capabilities, we're able to see where that freight is and able to begin to re-engineer the supply chain today for autonomy that's coming yet in the future. And then the digital transportation system is how it's implemented. So it's one thing to understand how big the opportunity is. It's a whole nother thing to talk about how you're actually going to go take advantage of that and harness these transactions day in and day out. Pick up, deliver, pick up, deliver, pick up, deliver. And there's so many complications that weigh into those decisions. Driver time off, driver requests for home time. What is the service requirements on the particular load? Are the assets ready to load the trailer? Are the assets ready to position the tractor, and so forth? The digital transportation system actually focuses on creating a schedule and a plan that literally day in and day out, everybody knows who does what, when, where, why, how, and with whom, in order to make this $120 billion marketplace come to life for you specifically. So now let's talk about the baseline architecture of every truck. Now, both of the tractors in the convoy are configured exactly the same. They're configured for a level 4 driving situation for the autonomous vehicle. Now, I'm going to point out that even though the lead vehicle is fully equipped to operate at level 4, it will only operate at level 2 with a human driver because it is a human-guided autonomous convoy with only one truck, the follower, operating in follower mode.
Glynn,
So the standard configuration includes this redundant steering capability from ZF. Now, we're actually co-developing this with ZF in partnership for the joint development and testing of these systems. When you talk about redundancy, the real two primary areas that you're dealing with have to do with the steering capability and the braking capability. The easy part really is the acceleration. And so there isn't a lot of redundancy that's built around accelerating a vehicle. But for steering and braking, these two major components are the areas that, that we're focused on building redundancy in. The vehicle also includes the sensor capability that we built right into the mirror pod. So the sensor capabilities, it's multimodal. So you've got cameras and LiDAR, and you've got radar capabilities. You've got built-in V2X communication capabilities, and this is where the two vehicles are communicating with each other as they run in autonomy mode in a human-guided convoy. And so the entire capability is an upfit that we're implementing with Rush Enterprises. So as the vehicle comes out of the factory, it will go to Rush Enterprises for the post-dealer installations, and that's when all of the capabilities are implemented in order to create an autonomous, capable truck.
Glynn, let me ask you a couple questions.
Yeah, you bet. Go ahead, Tommy.
First off, I'm interested in Rush because Rush has an insurance element, and some of those people probably listen to this program today because they're a member of the foundation. Just to let you know that we have a relationship with Rush in that part of it. But this is retrofitted then. This puts in the truck after it's manufactured. So there's nothing at the manufacturer level that goes here. You add this later through the dealerships, right, to install it.
That's correct.
So
yeah.
And what he talked about, level 4 is with no driver. Level 3 is with a driver with the autonomous vehicle components in it. Level 2 is what? There are 4 levels, are they not, Glenn, in the autonomous as far as the nomenclature goes?
Yeah, there's actually 6 altogether. There is 0 through level 5. And think of level 0 as just being, you know, an old Ford or just an old truck. Level 1 has cruise control and some limited capabilities. Level 2 really has more advanced driver assistance systems. So these are lane keeping capabilities. This is adaptive cruise control. It is collision avoidance.
Collision moderation. Okay.
Yeah, exactly right. And so that's levels 2 and 3, and in varying degrees of functional capability and safety capabilities. The level 4 is the first level where you actually have a driver out, and typically we refer to the current model vehicles as sort of being level 4 ready. So it has a steering wheel and brakes and pedals and and a seat and all that for a human. But level 5 is where you actually get to where the vehicle itself is really nothing more than a tug. It doesn't need any of the driver accoutrements. It literally is just a utilitarian device that has the powertrain, the braking, the steering, and of course the sensor capabilities built into it. But it doesn't really, in a true level 5 environment, it really doesn't look much like today's modern vehicles.
Thank you. I just want to refer that. So the 4 level is the stuff that's to a truck that can run without a driver behind the wheel is what we're talking about.
That's correct. And it has to be able to get to a safe state without a driver intervening at all. So in our particular case, our driver is going to be off duty, not driving. Some people say they won't get in the buck and sleep, but they actually will get in the buck and sleep once they get comfortable with their machine. And so when that driver's in the buck, off duty, not driving, that vehicle has to, if it gets separated from the convoy, will have the capability to come to a safe stop, that get to a safe haven and ensure that all the occupants, are secured properly. So that's what we're focused on at level 4.
Of course, that's the big key here, to maximize hours of service, to maximize the asset of the vehicle, to travel more miles without a driver having to be behind it, with limiting them with their hours of service requirements. That's a big key too.
Yeah, that's absolutely right. In fact, when you start having the vehicle continue to roll while the driver's off duty, it really does provide for tremendous revenue production opportunities. But the real key is that now you've got really some additional available capacity, because it doesn't rely on the driver's hours of service to be able to roll the truck. The truck rolls because that's what it's programmed and designed to do. So you can produce miles while the driver's off duty, not driving.
Thank you for that.
You're welcome. All right, so coordinated operation through human-robot symbiosis. So this is really just a fancy way of saying that we have a human driver who's actually focused on the task of driving. So what this does is it makes it easier for us to validate that this is a safe solution, primarily because that driver in the lead vehicle is making most of the cognitive decisions about where the convoy is going to go and how it's going to operate. The autonomous follower vehicle, interestingly enough, is functioning in absolute near real time in terms of understanding what the leader vehicle is seeing and doing and experiencing, so that in the case of, for example, coordinated braking maneuver, like you see down here in the lower right-hand side, the follower vehicle, the moment that the leader vehicle takes their foot off that accelerator, that truck itself actually knows that that has occurred, and the moment the driver begins to touch the brake, the vehicle that's following has an instantaneous awareness that this is what's taking place. And so this gives us the ability to really truly to deploy this technology and this capability faster than having to design for every single work zone and every single potential issue that could take place on the tractor, primarily because that leader driver is engaged cognitively in the process of driving. So when they make a maneuver and the systems are aware of it in sub-second timing, you've got really a solution that can scale quickly, can prove that it's a safe solution, and actually be commercially and economically viable for the purpose of hauling freight.
Glynn, this is interesting, but let me ask this. Going back to the Terminator movies, now, are we teaching the system these things the first driver is making so they can down the line be able to do it on their own? Is that a part of this, that the system's picking up why the driver's doing that?
Yeah, absolutely. That's a great point, Tommy, because in the leader vehicle, so while the leader vehicle is not in autonomy mode, it is actually in shadow autonomy mode. And so it's constantly assessing what the driver is doing and comparing that against what it would do in a similar situation. And then the system actually snips out those incidences and sends those to the developer, so the developer can understand what's taking place, can ask the driver, why in this situation did you maybe, jog to the left instead of jogging to the right like the machine would have done, and they reconcile that. And through doing that, that actually helps you get, into this long tail problem faster, because the commercial viability of these trucks actually hauling freight and making revenue while rolling out the autonomous systems and doing it in a safe fashion gives us the ability to put billions of miles on the road in real world scenarios to see all of the different situations that the vehicle may face. And even then, it isn't all of them, because we're never going to be at the end of that. That's why they call it a long tail problem. But nonetheless, we can test it in real world conditions and really take those snips and study those and understand how the system needs to grow and learn faster and better to be a safer part of the on-road community.
Another advantage of this, though, and this gets some of the debate, it's still a driver controlling everything, but he or she's getting more help than even the level 2 and 3 has, because now they're questioning some of the moves, so the driver has an override ability, but he or she can be alerted if there's a better decision. So that's a real positive thing, not only learning, but giving the ultimate help with the driver.
That's right. That's exactly right. And this really is, when we talk about symbiosis, or the melding of the human and the robot together, it really is the best of all worlds. One of our taglines is human guided autonomy. And we like that because we believe that the world has the ability to harness these capabilities without giving up control, without giving up, their involvement in the process. It's really now the human using the machine versus the machine just going off on its own. It's the human actually using the machine to improve society and to add value to the economics and to, make life on the road easier for the driver and, of course, safer for the motoring public. All right, and I'm trying to advance to the next slide. There we go. Got a little out of hand there. Hang on just a quick second. Let me make sure that. Okay. All right. Get just a 1. Goodness gracious. All right. Sensitive robot here. So we talked about the phased approach to autonomy earlier in that slide where I showed you the 3 components of our total solution. On that far left-hand side was the autonomous truck systems, and I mentioned that we're going to roll that out in 4 phases. Here are the 4 phases. The first one is the autonomous relay convoy, where you have a human driver and a driver in the follower vehicle who's off-duty, not driving. And of course, the tremendous advantage of that is that you can keep the wheels rolling, keep the truck making money, even when the driver is out of service hours available. And when the follower driver is well rested and the leader driver is about to end their shift legally, then these 2 vehicles can swap and the leader becomes now the follower, goes off duty, not driving, and the former follower is now the leader on the clock, taking hours of service into account and driving the convoy. The second phase is what we refer to as the drone follower. Once we've proved the safety case around the driver being out of the driving task in the follower vehicle, and the follower vehicle is in full autonomy mode and it's learned a ton, then we've got the ability to remove the driver from the second vehicle and actually have a leader vehicle, leader driver, essentially pull a fully autonomous vehicle to a particular point on the route and wait for a local driver to get there and, of course, finish up the load. But the drone follower allows us to go in really shorter lengths of haul. Longer lengths of haul obviously work continuously as well. But the idea here is that you could run a shuttle operation of vehicles into an environment where you have local drivers who are actually doing the local activity. Phases 3 and 4 now get into fully solo driverless. So this is a single vehicle that has no human driver intervening at all. And the phase 3 of that, which is the first solo driverless phase, is hub to hub. This is where vehicles are staged at each end of the autonomous relay network with loaded trailers. And then, of course, they're off on the road to get to the next point in the autonomous relay network, a node, if you will, or a hub, and find its way and then wait for a human driver to take over and do the local deliveries. So the idea of this is that you've got a constrained operational design domain around long interstate segments with a point at each end that's supervised, and then obviously at full autonomy in that line haul route. And then the phase 4 will then be sort of the nirvana of autonomous vehicle rollouts, and that's where the vehicle itself just goes dock to dock. So it picks up at one location, transits all the roadways and of course the interstate, gets to the other end of it, find its way to the other dock, and is able to deliver the load safely and on time. So those are the 4 phases of the autonomous truck technology that we're deploying.
Glynn, real quick, I know that we have been speculating timeframes on this, and I know there's state laws and other things required in here. Roughly time-wise, phase 1 sometime next year this time, maybe?
Yeah, absolutely. So we're continuing to test the vehicles. Wilson Logistics is our first deployment. We'll have some updated news coming out about some new autonomous relay network segments that they're going to be deploying. But in the meantime, we're getting test vehicles out on the road and continuing to move the ball forward to full deployment.
Phase 2 and 3, 5, 8 years down the line?
Yeah, so we believe that phase 2 will probably follow phase 1 by maybe 8 quarters, 6 to 8 quarters. Of course, everything is subject to change when you're talking about a whole lot of things that we still need to learn. But that's roughly the time frame, 6 to 8 quarters following phase 1. And then phases 3 and 4, I would say we'll be getting into the second half of the, this particular decade as we see those phases come to pass.
Thank you. The real one, and we're starting saving money in phase 1. I'm sure you're going to talk about this. Let's go move that part. This is the big key to it.
Yeah, that's absolutely right. That sure is. And in fact, here's where the money really is. When you talk about this first phase, autonomous relay convoying, it's in this middle mile section. So this is the operational model that we've set up. So when we talk about the autonomous relay networks, they are engineered to maximize the utilization on the middle mile. And when I say maximize it, we're looking for 20 to 22 hours a day of continuous operation on the line haul, moving freight back and forth or relaying it on a continuous journey from one end of the nation to the other end. We are also setting up this local activity at the first mile and the last mile. And these are non-autonomous operations in the first mile and the last mile, which is why we want to reduce the amount of time in that particular phase to about 5% of the total trip time on each end of it. So the vast majority of utilization up on the mile, and that's really where we think the first rollout of autonomous trucks is really going to produce a tremendous amount of revenue and profit. And I'm going to make some bold claims in a few minutes here, about how profitable it's going to be. And this is really kind of the solution to making that happen. And it is maximize the total utilization in that middle mile, and frankly, maximize utilization on both ends of the local activity as well.
So I just want to summarize my view. The first phase, first 5%, first miles, 2 drivers are driving vehicles, each controlling their own vehicles. The 90%, the middle, is where we have 1 driver leading, 1 driver sleeping, and maximizing hours of service, and going back to 2 drivers driving 2 vehicles not connected in the last 5%. So 90% additional utilization with only 1 driver, or at least a driver who could be resting. And I'm sure you're coordinating hours of service rules to make sure that you get the maximum use of the drivers while they're resting that part. But this is the big key to it.
That's exactly right. You hit the nail right on the head, Tommy. So the autonomous relay network, going into just a little bit more detail on this, these are 68 route segments that overlay the existing interstate network system. What we've identified is about 88% of the nation's freight can function in an autonomous relay fashion. It's a tremendous amount of freight. The opportunity is probably as big as this industry has seen ever. And I'll say that, from the start of the Industrial Revolution until now, this really has the capability of making a huge difference in how freight moves. We talked about the local pickup and delivery capability and the fact that we're going to focus on the middle miles. Between the points of these dots are what we were referring to as the middle mile. On average, they're about 480 to 500 miles in terms of length of haul. We understand both the revenue and the cost modeling on these segments in each direction. So north-south is different than south-north in many cases. East-west may be different than west-east. Has to do with, you all know this, freight balance and lane balancing and pricing is a market-driven function, but having visibility to it gives us the opportunity to really talk in terms of hard dollars and cents, real revenue, and real bottom line profitability. And again, I'll share some of those details with you in a moment, but that is the autonomous relay network.
I'm sure you use an actress study on the congested areas to stay out of those and put them in less. Also, I see that we're moving out of the port of LA as quick as we could, and Long Beach and San Diego, and get it as far east as possible, as quick as possible, the longer routes. That was interesting too, just looking at the map.
Yes, yeah, absolutely. And we do use ATRI, the American Transportation Research Institute, as the baseline for revenue and cost. We also use a platform called Sonar from FreightWaves that gives us an understanding of how the markets are changing day in and day out in terms of pricing. And then, of course, we use the Freight Analysis Framework, which is I'll say forms the basis of understanding how much freight transits the nation's interstates day by day by day. So it's from the Bureau of Statistics and the Department of Transportation, and it's really kind of referenced as the holy grail of freight movements each day in the United States. So good, solid basis in science in terms of how we engineer this autonomous relay network. Talking about the autonomous relay network efficiency. So if we look at just this in terms of the autonomous relay network segments, this particular route, and this is just one of many, between Omaha and Chicago, the current over-the-road metrics are driver utilization about 86% in this case, tractor utilization is 43%, and the tractor emissions is 676 metric tons of CO2 and greenhouse gases and all that nasty stuff that that pollutes the air. So that's the current over-the-road model that we're looking at today. When we implement the DTS operating model, of course, you still get the driver utilization today because we don't have the autonomous trucks yet. But the tractor utilization is what you actually see the tremendous improvement from. So when we talk about unlocking available capacity, we're doing it because we're no longer reliant on the driver's hours of service to enable the truck to move. And therefore, it continuously moves. We get the utilization up, earning more revenue and profitability related to that because the costs associated with not idling the vehicle as much. By the way, tremendous improvement in greenhouse gas emissions. So it went from 676 metric tons down to 594 metric tons. And so that is a fairly tremendous lift in terms of the capabilities of even pre-autonomy. And then the last section over here, and I'm going to just say right now, I cannot see because of the webinar panel on my right-hand side. Let's see if I can move this. I can. Now I need to see the screen again. So in the autonomous relay convoy, we're getting driver utilization up now. So this is when we actually implement the hardware, the autonomous truck system, so that the follower vehicle can go into autonomy mode. Now we see the driver utilization driven up tremendously because of the miles that the truck is accumulating without the driver actually having to be on duty. So they're not bound by the hours of service regulations. They can literally be in the vehicle, while it's in autonomy mode in the follower position and gain that driver utilization. Same level of tractor utilization because we're still getting 20 to 22 hours a day of continuous movement. But now you have, as a result of the autonomous systems and the close follower configurations, the drafting and other capabilities that allow it to burn less fuel running the same amount of miles, the CO2 emissions is reduced now to 528 metric tons. So it started at 676 metric tons. Then it was 594 metric tons when we engineered for the autonomous systems. And then we implemented the autonomous systems, we produced 528 metric tons. So an improvement each time we advanced through the cycle.
So you introduced the greenhouse and all the environmental questions at the same time, as well as utilization. That's a double whammy there, Glynn. That makes a lot of sense.
Yep, yeah, and it's a fun little model when you kind of see what you know, how it progresses and how it benefits everybody, not just truckers, but also society as a whole. I'm going to talk in just a minute about what those greenhouse gas effects are. But before I get there, speaking now in a little bit more detail about the digital transportation system. So these are tools and systems and methods and processes that we actually implement at a carrier when they're looking to introduce an autonomous truck service. Again, just having the vehicle show up and know what to do, it isn't going to happen. So this system actually plans and schedules down to the detail, down to the nth degree, who does what, when, where, why, how, with whom, so that the entire system can actually transact this business. And when we talk about unleashing $120 billion of autonomous relay freight, unless you have the systems to implement it in a model that can sustain those transactions day in and day out, you're going to be less than successful. That's why we're implementing the digital transportation system, though, is to help you be successful in implementing this service model for the clients that you serve. So Tommy, you hit on the cost savings question just a minute ago, and so I'm going to actually go into a bit of the details here. So we are using for the baseline set of data here, the ATRI information. So they do a great job on surveying the marketplace and understanding carrier costs on average, and so we're using those particular numbers. The cost savings that we derive, that we actually produce, come in the primary forms of the driver, the fuel consumption, and then other items that are related to the purchase of equipment and the fixed costs associated with owning those assets. So driver, fuel, and then asset costs, insurance costs, permitting, and so forth are the three primary cost savings that we're focused on reducing. And then, of course, if you're looking at a solution, you've got to add back in the costs. The fact of the matter is you know, you can do almost anything if money doesn't matter, but the truth is money does matter, and especially in trucking. And so there's a factor that we've considered in terms of the cost per mile of the locomotion cost, just so that when the carriers look at this, they really understand what the costs are and are able to understand where the money really is coming from. So in the current environment, the drivers are functioning at about $1.71 a mile. Again, this is on average using the ATRI database. And then of those, the driver cost is 74 cents a mile. The fuel cost is 41 cents a mile. And then the other costs are 57 cents a mile. And again, the other costs are things like the amortization of the equipment, the insurance costs, the permitting costs, the licensing and registration costs, and all of those that just, even if the truck doesn't roll, you know, those costs still exist. And so in the environment that we're talking about rolling out first here, which is ARC, so we see a reduction in cost per mile from $1.71 a mile to $1.46 a mile. And the primary place that we're getting that is in this driver cost. So when you have a driver off duty not driving, even though you may pay the leader driver a premium for leading the ARC convoy, the driver in the follower vehicle can go on a different pay scale. We also see an improvement in fuel consumption as a result of the close following and the drafting capability on those vehicles. It's been estimated that The savings of a close following convoy is about 8% fuel economy improvement for on average for both of the vehicles. So there's actually a benefit for the leader vehicle in terms of aerodynamics, as well as the follower. I think we all understand the follower benefits just in general, but the leader does participate and has been proven through fuel studies that there's an improvement in overall fuel consumption reduction on both of the vehicles. Again, so we see a reduction to about 38 cents a mile for fuel costs. And then related to using fewer vehicles to haul the same amount of freight. So drivers and trucks, big improvement in the number of assets that you actually need to run autonomous relay convoys. The reason we start with the planning on the autonomous relay network is to set up these relays and these tours, these trips in such a way that their utilization is enough to where you don't actually have to put a whole bunch more assets into the mix in order to service and deliver the same amount of freight. So the improvement in utilization is primarily where you're going to get the pickup in all of the other costs. And then of course we do roll in the cost of the locomotion system. It's dependent upon the length of haul. So we used an average here within the autonomous relay network segment of about 480 to 500 miles roughly in order to make a determination here as to the total effect of the locomotion cost. So that's with the autonomous relay convoy. And then this last progression to the far right is as a result of going into a fully driverless environment. So this is a solo truck with no human driver, cost per mile at about $1.12, primarily because you take out the driver cost per mile altogether. You do have to give back a little bit of the fuel savings because a solo autonomous truck will not be drafting or close following on vehicles that are ahead of it. So we had to give back that fuel savings because you won't be getting that. And then of course you still maintain the same utilization rate. So you're still not purchasing an excess of capacity in order to deliver that same amount of freight. So here's the progression in the cost per mile. And this is why at scale, when you talk about 1,000 mile or a 2,000 mile journey, cost per mile makes a whole lot of difference when you're talking what they're doing today versus an autonomous relay convoy model versus a fully solo driverless truck. And of course, this is where we're shooting for, but this interim step is going to be a huge benefit to those who participate early in this process.
Glynn, for people that don't watch NASCAR auto racing, they might not understand the savings of both of them pushing them. But the idea of platooning and those things is a very important. That's that second level here, and that's that fuel saving. But with 100,000 miles a year, you're talking about $25,000 a year on this second model, and then obviously almost $60,000 in the last one. Obviously, with the fuel cost up, you can run these numbers again to be slightly more favorable to you at the current price of fuel versus when Atri did this 2 years ago.
That's right. Yeah, absolutely. And of course, you know, as costs change, and right now it just appears that they're going up with inflation and whatnot. The benefit we do expect to, you know, to continue to accrue to the carrier at these costs. The payback period we'll see on one of the following slides is about a 7-month payback period. And depending on the lengths of haul, it could be 7 to 11 months. But nonetheless, it begins to pay back pretty quickly.
Driver pay is going up too. So snapshot in time, this is a more favorable situation, both from driver pay and fuel costs that you're comparing against. Today, those numbers are up. So this savings would even be more. But all you can do is look at snapshot. Go ahead, Glynn. I'm sorry.
That's exactly right. Snapshot in time makes all the difference. And speaking of the snapshot, this is the carrier return profile that we've developed based on the claims that we made. Now, I want to address this, the claims that we're making. These are bold claims, and we recognize that. And so what we have recently done is we've gone out to a company that specializes in validating the greenhouse gas emission claims of companies. So this particular firm is called Boundless Boundless Environmental Research, and they took our claims, they took our science, they took our models, they took our math, and they ran it through the ringer to determine whether or not it was accurate, whether or not we were essentially, overblowing it. And what they came back with was on a scale of 1 to 10, with 10 being the very highest score that they would give a company making claims like this. They determined that we were worthy of a 10 on that scale of 1 to 10 in terms of the validity of the claims that we were making. And what this means is that a carrier who chooses Locomation can go to their shippers and can share with them these reductions that they're going to deliver as a result of hauling that shipper's freight on Locomation equipped trucks. And now that shipper can actually go to the marketplace and they can borrow money for less cost because they now have a plan to reduce their greenhouse gas emissions. They can go to the street and they can boast about the fact that they're going to reduce their greenhouse gas emissions by some 22%. And those, again, are bold claims that really needed to be validated. They were validated. And so now we can go to the marketplace and publicly claim that these numbers are fully accurate and that you'll be able to prove this as the technology deploys, and you can count on it in terms of your plan to reduce greenhouse gas emissions. So we talked about this return on investment model. And again, the idea is that for every mile that's driven, when you look at the operating margin per mile, again, using the current, using the autonomous relay convoy system, and then using the fully autonomous truck system as our baseline models, and a flat revenue rate per mile of $1.83, just using it for this example, and you can see where the profit accrues as you begin to compress these costs per mile. And literally for every mile driven, you earn additional profit from where you've been previously.
And that's it. You have one factor here that you haven't even thought about. Because there's less drivers needed, there's going to be less cost of recruiting and screening and all the other kind of things that not even factor in here, because you're going to have fewer drivers going the same productivity, and that's going to be the thing. And with all the driver shortage and everything else we're hearing. And I also thought, Glynn, that this is also something when we worry about the younger drivers, this model where you have the first truck controlling and the person in the sleeper in the back, that's ideal for someone with less experience, because you all expect that their experience is coming from the first truck. And so they're sitting there being controlled by that first truck, but you'll have a less experienced person in the back to bring more people into the system. I think that's also positive. I don't know if you publicize those, but when I've talked about this, that's what I always look at is that entry level new driver. How do they get experience? This is a way they can get it without increasing the risk of a crash. Or at least significantly.
Yeah, that's right. And you know, when you think about the latest numbers out, say that we're about 80,000 drivers short, you know, heading into the next couple of years. If we were to take and just put 10,000 trucks on the road that didn't require a driver in that follower vehicle, it would make the leader driver not only more productive, but it would allow them to introduce capacity that they weren't previously able to introduce, and that is for that truck, without actually having to go and recruit a driver. So that, to your point, Tommy, about the recruiting costs of the drivers. But the other part of it is, if these trucks were available today, you could literally put them in service tomorrow and have all the freight that you need to haul, those loads, have everything that you need, the assets and whatnot, drivers included, because in the follower, you just don't need them. So, nobody has to worry about losing a job because of these autonomous trucks coming, not within any of our lifetimes. What you can count on is the fact that you'll be able to produce more, really just kind of being your own boss as you run your autonomous relay convoy. And the numbers here are quite compelling and say that it's going to be well worth it. All right, so we'll kind of finish up with this. I told you that I was going to make a couple of bold claims. I shared with you about the Boundless research report that validates our claims. These are the real two numbers that, when you get right down to it, make the biggest difference. This operating cost reduction of 30% is an improvement on a per mile basis that literally accrues to the bottom line as the truck rolls. These operating costs are real. Part of it is the fuel consumption reduction, and that's what produces this greenhouse gas emission reduction. And this is per truck per year. These are fantastic numbers that the shipper community has been looking for a way to solve for really a decade or more, because out of the diesel fuel emissions, it just is very difficult to even gain 1 or 2% of fuel efficiency. And of course, with each 1 or 2% in efficiency comes a reduction in the fuel that's spent, and then the improvement in the amount of pollution that it's creating. When you talk about a 22% reduction in greenhouse gas emissions, this is a number that literally is going to move the needle in the shipper community. Coming out of the latest environmental meeting that took place in Scotland in 2021, a lot of emphasis was put on diesel fuel emissions, and a lot of the responsibility shifted over to the shipper to take a look at their purchase transportation and do what they can to reduce the amount of carbon emissions. And so now the carrier has the ability to play in that storyline and help make it happen, but not just make it happen in a little way, make it happen in a very, very big way.
Glynn, practicality, there's a lot of laws that you're going to have to look at on this too, is it not? Because in some cases, following this close is reckless driving. I'm sure you're working on the legislative part. And I think right now, the favor in Congress and Washington, no matter who the legislation or the party enforces, everybody's in favor of this part of it. So the idea to change some of these laws to be more practical to make this work, you're finding success and support there. Are you not on both sides of the aisle?
Yeah, that's correct. In fact, the current environment for autonomy really favors this human-guided approach. Everyone is concerned with heavy-duty trucks having no truck driver in them, and frankly, they should be. There just is a long way to go, to make that happen. But as we talk to regulators, both the federal and the state regulatory environments are highly favorable to this type of technology. We've hired a gentleman by the name of Finch Fulton, who's the former assistant deputy for policy at the United States Department of Transportation, and he is our vice president of regulatory strategy, and he is laying out a 50-state strategy where we're actually going to each state that we're deploying in, and as we deploy it, and working with each one of the states, to ensure that we're, functioning legally within their state, that they're aware of the testing that we're doing and the deployment plans that we have. But we expect really for a human-guided autonomous model like this, where you've got an autonomous truck following a human-supervised convoy, we're expecting to have really very few headwinds as we deploy that model, and we're getting support at the state level as that occurs.
When I was on that panel in San Francisco with autonomous vehicles, a regulator from Florida came up with a good idea, or made sense. Move the truck lane to the left so people don't whip in and out going down the exit lane. I'm sure you all have addressed that too. That would be a very simple part of the system here, and that would take a lot of training, but would be practical without any problems or anything. One other thing, I know also some of this is being done now outside the U.S., is it not? To some extent, platooning and all this. Are you involved in any non-U.S. development of this, and have you found some testing in those other countries?
Yeah, we've actually found that there's quite a bit of development altogether in autonomous trucks, but really very few are focused on this convoying model. Okay. What we see is kind of everybody looking to jump straight into a fully driverless truck. And we think that the money market is really going to favor the commercially viable approach first, and then the whole grand strategy later. The grand strategy is worth it. It's worth doing. It's just a question of how long will it take for the truck to know exactly what to do in every situation so that it's not involved in an accident. So we think that that there's a worldwide model for this. We are looking at other areas, and with great interest, and we think it's going to be the timing is going to be right when each country has an environment that will support it. We think we can make money for the clients we serve in each market throughout the U.S.
And obviously make money for yourself, which is the bottom line, but that's the deserving part of it. You know, this has come a long way from when I first met you 4 or 5 years ago. Talking, we had done this. And for you who were not involved in this, Glynn was supposed to be at their annual conference last year in October, rolling this out, but he ended up getting COVID at the last minute, so we did not see his picture there. Looking at that, we're glad you're here. Glynn, really appreciate you spending the time for us on this, and we thank you very much.
You're welcome. Thank you, Tommy.
So for information on all MCIEF offerings, including membership, PRS designation, Trucker U, or classes, visit our website, mcief.org. We'll look forward to you participating in next month's webinar, again, the second Thursday of each month at 2 p.m.